Hello, my students at home and viewers. Online with you is Ofojee Euch of Mathematics Department from St. Charles College, Onitsha. We are going to discuss the topic sine rule. And before we go on to the topic, I want the students to bring out their calculator and four-figure table because we are going to discuss the value of angles, which we are going to look into the four-figure table or calculator. Thank you. The specific objective, that is what you are expected to get this in this lesson, is that at the end of this lesson, you can be able to state sine rule and you can also derive sine rule. We are going to use angles that are up to 90 degrees and above. Using right angle triangles, we have that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we are going to use this previous knowledge, for we don't have any other knowledge of how to solve right angle triangles except this right angle triangle, and that is why we are going to bring in this previous knowledge to derive the sine rule, which says that sine A over small a is equal to sine B over small b is equal to sine C over small c. Now, I want you to look at the two figures. The first one at the left-hand side is an acute triangle. You can now see the indication of the capital A, small a, capital B, small b, capital C, small c. You can now see that those small a, b, and the c are in the side of the triangle, and the capital ones are in the angle itself. So that's distinguished between them. So that left-hand side is acute angle, and the other side is obtuse angle. We are going to use it to talk about these right angle triangles. As you can see, I have discussed with you and I have told you what capital A is and small a, and that is what we are going to use in this. We are going to use the two figures, the acute angle and the obtuse angle. We are going to use it to discuss the proof. So we are looking at two different triangles again, but if you look at it very closely, you can see that there is a line that divides the triangle into two, and that line, we have it as a small h. While it's divided and while the line is being added, it's because we are going to use sine, cosine, and the tan. And that is what will help us in discussing this sine rule, because we have not known any other triangle. It's only this right angle triangle that we knew. So we are going to use these two triangles. Remember, the first is acute and the second is obtuse. Now, we are going straight to the proof. We want to use the first one that states is an acute, that is a triangle that is less than 90 degrees. If we are looking at it and we want to discuss that, we want to bring out what is there. And what they ask us to do and what they ask us to prove is that sine A over little a is equal to sine B over small b and is equal to sine C over small c. Now, if we get to the angle at C, which is still acute, we can see that if we want to find h, it is sine that we use, because that h is in the opposite side and that b is in the hypotenuse side. So h over b is equal to sine C. And if we make h the subject of the formula, you see that h will now be b sine C, and we have it as equation 1. Also, if we get to the angle at B, we want to also make h the subject of the formula. And you can now see that h is also C sine B. We have it as equation 2. In figure 2, we can see that the angle C is obtuse, angle that are greater than 90 degrees but less than 180 degrees. So we are going to look for H again in that particular figure. And that is H over B equals sine C. If we make H also the subject of the formula, we have it to be B sine C, and we call it equation 3. Likewise, if we want to discuss angle B in the same obtuse angle, we have H to be C sine B, which we call equation 4. From equation 1, 2, 3, and 4, we have that B sine C is common and they are equal. Since H is B sine C and H also is C sine B, therefore B sine C is equal to C sine B. Good. Having seen that they are equal, we want to get where we are going. We divide both sides with sine C and sine B, and that is what we have. B sine C equals sine C sine B. C sine B over sine C sine B. And when we divide it, you see that sine C, we cancel sine C in the other side, which leaves you with B over sine B. And when we divide sine B and sine B, you also see that what we have there is C sine B. Similarly, if you get the other side, which is A, if you want to discuss the angle A, you also see that what we have in common will be B over sine B equals A sine A. And now bring us to the conclusion of what we are going. We have seen that A is there, B is there, and C is there. And so what we have is the conclusion of the proof. A over sine A is equal to B over sine B is equal to C over sine C, which is the same thing as sine A over A equal to sine B over B equals sine C over C. For the students who think that they always leave the sine A above, the one that you leave in the numerator or in the denominator does not matter. Two of them are the same. If you want to put sine A in numerator, you are free. If you want to use it as the denominator, you are free. But we have come to the end of the proof that says that sine A over A is equal to sine B over B is equal to sine C over C. Now, we want to use it to solve problems. Calculation using sine rule. In example 1, we want to look at triangle ABC, where we have A to be angle 29 degrees, B to be angle 36 degrees, and line that is facing B is small b is 15.8 cm. Now, you can now see that we are combining A and B. So what we are going to use is to pick out the two acts of the main rule to discuss, and we want to find small c. We want to find small a. A over sine A equals B over sine B. Now, we want to fix what is there. Remember, they asked us to find A. And now, we have A, which there's nothing. But in A is sine 29 degrees, and B is 15.8 over sine 36 degrees. You can now see why I asked you to bring out your calculator and your 4-figure table. If you use your calculator, you will see that sine 29 degrees is 0.4848. Also, sine 36 degrees is 0.5878. And when we multiply 15.8 and 0.4848, we have it to be 7.6598 over 0.5878. And that's when you now use your calculator to divide through, you will see that the end answer will be 13 cm to 2 decimal points. Now we go to example 2. Having known what capital is, what small is, we can now look at it directly. We might not draw the triangle again because you have seen that A, the capital and small, you have distinguished that. So we are going to look at triangle PQR, where capital R is 53 degrees, capital Q is 42 degrees, and small r is 4.3 meters. We want to find Q. Since we have seen that capital letters indicate angles and small letters indicate side of the triangle, we will choose the rule to solve. And what we are going to use combination is Q and R, where you have seen what is that. And Q, the capital Q is 48 degrees, small q is what we are looking for, capital R is 53 degrees, and we are given small r to be 4.3. And when we look at the calculator or four-figure table, you also see that sine 42 degrees is 0.6686. Then you use it to multiply 4.3, and you use 0.7986, which is the value for sine 53 degrees. And when you divide it, you see that when we keep it to one decimal point, the answer becomes 3.6 meters. We are going to look at example 3. We want to find C from the figure. But when you look at the figure, you will see that we have small a at 6.75 cm. And we are given capital C, which is the angle, as 82 degrees. And we want to find C. So they gave us the side of A, but they did not give us the angle. Therefore, we are going to use A and C. So we want to find angle A. And to find angle A, remember, my students, that the sum of angle in a triangle is 180 degrees. And since B and C are given, we can use this to find A. So when we add 39 and 82, we subtract it from 180, and we now get A as 59 degrees. So we now combine A and C. Now, what you say is 6.75 over sine 59 degrees equals C over sine 82 degrees. And when we get to the calculator, you will say that sine 59 degrees is 0.8572 and sine 82 degrees is 0.9903. When we multiply 6.75 and 0.9903 and divide it with 0.8572, we have the answer in 2 decimal points to be 7.78 cm. Now, we want to look at example 4. What I want you to detect in example 4 is there is a small one, or you call it minutes, on top of 15. But if you get to your four-figure table, you will see that very sign. And therefore, whenever you are given this type of sign in any angle, you have to first of all convert it to angle. And to convert that 15 minutes to angle, we divide it with what? 60 degrees. And so when we divide it with 60 degrees and approximate it to 1 decimal point, what we have 15 minutes to be is 0.3 degree. And so what you have as the answer now, which you can comfortably go with in the calculator or in the four-figure table, is 101.3 degrees. Good. We have come to the end of the lesson, but I still want you to remember, especially in the last example, how to convert minutes to angle, that you always divide it with 60 degrees. And also, you remember what we are told in the beginning of the lesson, what capital A is and what small a is, so that when you are putting it in the formula, you will be able to solve it comfortably and you get the answer. My dear students, I knew that you have taken the lesson. But before we say bye to the lesson of the day, I want you to use the following evaluation test. Calculate the values of small a, capital A, and small c in the triangle ABC. Given that small b is 17.23 cm, small c 10.86 cm, And the capital B is 101 degrees 15 minutes. Thank you. You use the WhatsApp number if you solve it or if you want any question to ask, and that is 07035365700. Thank you for listening and have a nice day.